So for part V, I'm gonna go ahead and say that this is not true. It says 20 can be written as the sum of an odd integer and two evens. Well, let's see. 200 equals, it says the sum of an odd. Well, here's an odd number. 2, 1 plus 1. That's an odd number. And then it says, and two evens. So plus, here's an even. 2k, that's even. And 2w, that's even. Where we have to tell the reader that so we can tell them where n, k, and w, what are they? What kind of animals are these? N, k, and w. N, k, and w are, they're integers. Right, that's the definition of an odd number. 2n plus 1 where n is even. 2k, that's an even number where k is an integer. W integer, 2w even. So they're saying that this can work, but I'm saying it's a lie. I'll show you why. So let's write this down here. So this is 200 equals 2n plus 2k plus 2w plus 1. You can drop the parentheses and put the 1 in the back. Now what I want to do is I want to factorize a 2 from these guys here. And I'll just leave the 1 in the back. So I take out a 2. And then you know what we can do? We can say that this is 2, pick a different letter from the alphabet. How about like Q? So instead of n plus k plus w, I'm just go ahead and say Q. And you tell the reader where Q equals n plus k plus w, which, I don't know if you guys have seen that symbol, but that just means element. So integer plus integer plus integer is an integer because the integers are closed. Closed means you add them together, it's still an integer. So I just felt like being elegant and I replaced these three by just one letter Q. So Q has been assigned to represent these three numbers. And if you add three integers, guess what? It's an element, that symbol means element of Z. And Z is the symbol that represents the set of integers. But now look at what we have. We're saying that 200 equals 2q plus 1. But look, what kind of animal is this? 2q plus 1 is an odd number because q is an integer. So do you think 200 is odd? Yeah, I know. So we have a contradiction. That's the symbol for contradiction. So you can write this in your own words, but definitely false. Now for part W, I agree with what they say. I agree completely. So I'm going to say that this is true. So for W, it says 20 cannot be written as the sum of three integers, an odd number of which are odd. So they're saying this. This has two cases. So look, 20 equals number plus number plus number. They're saying 20 cannot be written. So they're saying this cannot be true, where 20 could be written as three numbers where an odd number of them are odd. So it can be one odd or all three are odd. So this has cases. So case one, we're going to use one odd. So here's what I'm saying. So the first case is where of the three numbers, only one of them is odd. So I need an odd number right here. Well, here's an odd number, 2k plus 1. So I need a couple of evens. How about 2n and 2m? So this is a true statement. 20 cannot equal this. I'll show you why. 20 cannot equal 2k plus 2n plus 2m plus 1. I'm going to put the 1 in the back. So 20 cannot equal 2 times k plus n plus m plus 1. I'm going to do the same thing as before. And I'm going to say that 20 cannot equal 2, let's use a different letter. How about q plus 1, where q equals k plus n. It's pretty much the same thing as before, right? So look, this is true. 20 cannot equal this. How come? Because this is odd, but 20 is clearly even. So for sure, case one, it makes the original statement true, right? Because they're saying 20 cannot be this. And I agree with that. 20 can't be this. What's the next case? There's only one other case. Case two, instead of one odd number, we're going to use three odd numbers. Because remember, they said three numbers that are three numbers in total. And they said an odd number of which have to be odd. So it's just getting through the language. So they're saying that 20 cannot equal number plus number plus number. We did a case where we had one odd, now the case for three odd. So what are three odd numbers? Here's an odd number there, here's an odd number, and here's an odd number. So 20 cannot equal 2k plus 2n plus 2w plus, you know how 2k, 2n, you know how it's 1 plus 1 plus 1? I'm not going to call it 3. I'm going to call it 2 plus 1. I know 1, 1, 1 is 3, but I want to leave the extra 1 because from here, I'm going to take out a 2. So this is 2, and this is k plus n plus w plus 1 plus 1. And 20 cannot equal 2, let me pick the letter Q, plus 1. This one is right here, where Q equals the stuff in parentheses. K plus N plus W plus 1, because those guys are integers for sure. And so this is true, right? 20 cannot equal this, because this is odd and 20 is not. So the statement for part W, I agree, true.